My name's Eric Culver, and I'm in chemistry this year, and I'm in second block on B-Days. Today we're going to teach you a little bit about voltaic cells and electrolytic cell. First, let's go over to voltaic cells. As you see here, we have the voltaic cell. The anode is over here, and the cathode is over here. But first, let's notice our little sentence here. The red cat gets fat. What does that mean, you're asking? Reduction, cathode. Reduction is always with cathode. Cathode is down here. So this element down here is getting reduced. So, as we look in our voltaic cell, you notice there's a salt bridge. Salt bridges are normally for ions to travel to one side to the other. Let's look what elements we have. We have zinc and copper. When the battery starts going, we have the zinc electrons going towards the copper. So, zinc is being oxidized, which means it's losing electrons. It's losing electrons. And they're being traveled over to the cathode, which means that it's being reduced. So, under here you can see the half cell reactions. Zinc starts off at 0, and then as the reaction goes on, it gains or loses. It loses electrons, so it's the oxidation. Reduced down here is copper. Copper is being reduced, so it starts off with 2 electrons, and then it's gaining electrons.
Hello, I'm Gavin Craddock, partners with Eric Culver. I'm going to teach you a little something about chemistry. So, in chemistry, the anode flows to the cathode electron-wise. Now, the anode goes through a process called oxidation, which means that the anode loses an electron, but its oxidation number is increased. Now, on the other side, the cathode, it gains electrons from the anode, but the oxidation number is decreased. This is a diagram of an electrolytic cell. As you can see over here, the anode is silver, and the cathode is a spoon in this case. And the anode is used to coat this spoon in silver. And so the electrons from the silver flow following these arrows through the power source, which is very important because otherwise this reaction cannot take place. And so they follow the electrons to the spoon and silver plated. The two different kinds of redox reaction, voltaic and electric.
Voltaic, exothermic.
Endothermic.
Voltaic has a salt bridge.
Electrolytic has no salt bridge.
Voltaic, cathode has a positive charge.
Electrolytic is not spontaneous.
Voltaic, the anode has a negative charge.
Electrolytic, cathode has a negative charge.
The voltaic can have a voltmeter.
Electrolytic, anode has a positive charge.
The voltaic produces energy.
Electrolytic is used for electric plating. Electrolytic uses energy.
You might be wondering what they have in common. I'll tell you though.
Both travel from anode to cathode. Both redox reactions. Both use electrolytic solution. Both need electrodes. Both need ions.
Isn't that crazy?